Hello everyone, my name is Earl Alleluia. Yes, you heard it. That's how holy my name is. Alleluia. So, today I'm going to give you a video tutorial all about separable differential equations. And we know that separable differential equation is the first type of nonlinear first order differential equation. So a separable differential equation is a differential equation that we can write in this following form. So any differential equation that we can write in this following term is already a separable differential equation. So here in this equation, simply that it means that there is a function of n with y variables in it, dy is equal to a function of all x variables in terms of x that is and dx. So for example, m of x could be just like in this form: x squared plus 1, x squared plus x minus 1, or etc. That means, for example, in this term or in this function, this function contains only x variables. So that's how it means. And also with this function, it also contains only x variables. So now, in separable differential equation, what we're gonna do first, to relate all the differential equation or some differential equation in this form, that means a differential equation is having this form like this one, and then what we gonna do next is next thing to do is, yes, we have this, we have this is y. I'm just writing that equation. Okay, so that's it. So next thing to do is just integrate both sides. So if we have a separable, a recall, this is just a recall. So a separable differential equation, first step is to relate the differential equation into like this. So that means a separable differential equation has this form. And next thing to do is that we integrate both sides, and then we're done. So that's how easy it is. Now let's take some example. So for example, we have this equation: 2y prime minus y cubed cosine of x is equal to 0. So I think this is an easy question. So as you can see, the source of this question, this can be found out in the book of Advanced Engineering Mathematics by Ray Wiley and his friend, and then that is in the 5th edition, page 28, number 19. Okay, that book of Ray Wiley, that is the Advanced Engineering Mathematics. So this is the equation that we have to answer. Okay, so I may be needing one more paper. Okay, so our question is this thing, so I have to write it: 2y prime minus y cubed cosine of x is equal to 0. So take note, just y prime is just equal to dy over dx. So writing the equation, we have this: 2 dy over dx minus y cubed cosine of x is equal to 0. And then, so this is already the form. Not yet, since we have to transpose, or we have to separate all variables from x to the y. So what we're gonna do to transpose this equation, we have this equation: 2 dy this term, we have to put it on the right side of our equation. So we having this equation already. So the next thing is to separate all variables. So we have to multiply this by dx over y cubed. So we can write the form already in this 2 dy over y cubed cosine of x dx. Now take note that this equation could be is already in this form, right? So that means this is already a separable differential equation. See? So to integrate, the next thing to do is what? Integrate both sides. So we have to integrate both sides. So this is a constant, so I am just having to write this equation to make it simpler for you to understand how I integrate this. Okay, so that's it. So integration of y to the negative 3, just add 1 here, so it becomes negative 2, negative 3 plus 1 over, that is negative 2 over negative 2. We forgot the constant over here. This times equal to the integration of cosine x is just equal to positive sine x. And don't forget the constant c. So cancel this out. So this could be like in this term, or in this following form. Okay, sine x plus c. So I think this could be the answer already, and obviously I think this is correct. And we know, though we can simplify it more further, but I think this equation is more simpler to look at it and we can understand it clearly. And then I think it's more understandable, and then it is like a beautiful construction of the equation already. So I think this would be our final answer.